what we get. One person that's come in. Okay. I'm going to do a little chat and make sure they can hear us.
I suppose we should say something, right? We want to know if they.
Yeah, let us know if you can hear us. Let us know that you're there. Anything else? 17 so far. If you guys can hear us, anybody could want to go through the video chat, just go ahead and just let us know that you're there. Great, looks like they can. Okay, we'll give it just another minute and we'll get started.
Oh.
Okay, we're at 12:01, so we're going to go ahead and get going. Welcome, everyone. My name is Stephanie Aiden. I'm Executive Director of AIA here in Spokane, and we have our second webinar series, our remote, live, and local. And this go around, our topic is navigating the new normal with the simulation modeling for COVID-19. You will get one HSW credit today. The only way that we can really do that successfully at this point is for you to email me at office@aiaspokane.org. Email me your AIA member number for credit, and I'll go ahead and make sure you guys get credit for the course. So I want to go ahead and introduce our panelists today. It's Coffman Engineers as our presenters. They're a very reliable and perennial AIA Platinum Allied partner, so we're happy to have them presenting today. We have Tracy Hannigan, who's a principal mechanical engineer with Coffman, and we have Robert Gerard, who's a senior fire protection engineer. And our moderator today is Bryson O'Neill, who's a marketing coordinator at Coffman Engineers. They do encourage a Q&A throughout the presentation. There is a Q&A button area up either on the top or the bottom of your screen. Go ahead and submit those questions, and Bryson will go ahead and moderate those questions as they come in. And it'd be helpful to specifically say, is this for Tracy or is this for Robert? Tracy will present first, followed by Robert. And I know you guys know why you're here and the program that will be presented, but I do want to go ahead and list what the learning objectives will be today, since this is about continuing education for your AIA credits. The first one is a scientific background of COVID-19 transmission in occupied spaces and how this affects design. And the second one is how the built environment can be modified to mitigate risk of COVID-19 transmission to protect the health and welfare of occupants. And a brief background on the study of human behavior and pedestrian simulation modeling and considerations intended to provide safety. And the last one being how simulation modeling for COVID-19 can be used to develop strategies and operational procedures for safe reentry into social environments. All very topical for what's going on today. So we're very happy to have them here. And I'm going to go ahead and turn it over to Tracy. And please, again, feel free to send your questions in through the Q&A section of our Zoom app. Thanks, Tracy.
Okay. Thank you very much. All right, so can you see my screen?
Yeah, we can see the presenter view, just so you know.
All right. Perfect. Okay. So here's our presentation. I'm going to give a little bit of an intro and then let Robert show you the pedestrian model, and then I'm going to do some wrap up at the end. So this is just my contact information. If any of you have follow-up questions after the fact, you're welcome to send me an email or give me a call. So we all know now that the enemy is here, and we've had spillover from probably an animal virus that's entered into the human pathogen life, and we're all living with that right now. So pretty common thing to occur, but not common to have such a big pandemic. This is a screenshot from a website that I used to monitor the spread of the pandemic throughout the world. This was the earliest time that I took a screenshot on my phone when I was looking at the data. And it was so alarming to see that we had over 24,000 cases in the world. I had zoomed in on the map on China because there really wasn't much happening in the rest of the world of interest. And about a month ago, we were at 5 million cases in the world, just incredible growth. And yesterday I took another screenshot, and 9 million cases, so we're almost over the 10 million mark. So definitely we have a lot going on right now, and we're trying to figure out how to cope and how to deal with it. So the SARS-CoV-2 virus is what causes the COVID-19 disease, and primarily it's spread through droplet transmission. When we're close to people, we're either hugging them, or we're nearby and they sneeze or they cough on us, or we touch something. There's fomite transfer, where you touch an infected surface and transmit that into your body by rubbing your eyes, that sort of thing. But there's also spread that goes further than that. Probably not as severe as measles or tuberculosis, where small aerosols travel for many, many feet of distance and through the ducts and currents, but we're still learning more about how far that can go. But we know that there have been cases of transmission further than what was originally thought. So the SARS-CoV-2 virus is about 0.12 micrometers, but that's pretty tiny. But fortunately, when people shed that virus, it's almost always attached to a droplet. So when you think about filtration and how small of a particulate you can catch with a certain kind of filter, you got to remember that it's usually attached to a droplet and it's much larger, so it's easier to catch. But we're learning a lot, unfortunately, about super spreader events that happen, like the Skagit Valley Choir, where people were obeying social distancing, they were washing their hands, they spread out in the church, and they had 47 out of 60 people that became infected in a 2-hour choir practice. There's also the Guangzhou restaurant in China, where they had 10 out of 21 people in the room at nearby tables that were infected. One thing some follow-up studies by Dr. Lee showed, though, is that they had really poor ventilation in that space, and that makes a difference. We're going to learn some ideas on how to improve things with that. Other big super spreader events, weddings, events, there's been a big outbreak at several churches that have reopened as well. And then we learned quite a bit from a study at the University of Nebraska Medical Center, where they looked at people that were sick with COVID-19. They sampled particulates in the room, on surfaces, outside the room, and they found that there was viable SARS-CoV, well, not necessarily viable, but definitely SARS-CoV-2 virus located in all the locations listed there. So right now there are studies pending. We don't know if that virus can travel through a duct and land on a filter and live and be infectious. We don't know if it can be adhere in the inside of a duct somewhere or be transmitted through into a supply grill into another room. We do know that there have been patients with and without COVID in different rooms, and the people that hadn't had COVID-19 were not infected. And so that lends us to believe that it's not likely that it's traveling all over through the ductwork, but again, studies are pending. We do know that they measured it in toilet rooms, and I'm on the ASHRAE Infectious Diseases Committee. We talk about toilet flush plume all the time and how it can spread pathogens. And this was a study that was done back in December 28, flush a toilet, and there's still infectious pathogens that can be released time and time again. So we really want to start thinking more about putting lids on toilet seats. So we take a closer look at our surroundings. We look at the microbes that are floating around in the air around us. We're about 1/3 microbe and about 2/3 human by cell count. Our bodies are full of microbes everywhere. And as we interact with our environment, we're shedding microbes and we're picking up more microbes, either by touch or what we inhale. And we know that our whole microbiome affects our health. It affects people's mental health, our digestion. Poor microbial imbalance can lead to issues with our neurological development and our mental health. It can lead to inflammatory autoimmune diseases. So worry a little bit about everybody trying to clean up everything and wash our hands so much and bleach everything. What are we doing to our microbes around us? We really impact the buildings that we live in by what we bring inside with us, but also how we condition that air, the way we filter it, the way we humidify it, or what temperature we have. We build our environment, and then that environment in turn shapes us. So it really matters how we design our buildings. There are new tools though, and we're going to show you some new tools. This is one United States Department of Agriculture's Animal and Plant Health Inspection Service we do a lot of work for. They come up with dog sniffing program that's pretty effective, where they can sniff out avian influenza with a dog. And they're using it for medical purposes as well, sniffing out cancers in humans and things like that. So we have new tools for that. When we sample the environment, we used to set out Petri dishes and figure out what was in the air. Now we can take a swab and use PCR, polymerase chain reaction analysis. And we found that we were only seeing about 10% of the microbes that were out there when we used the Petri dish, compared to what we can now sample and test for. Much more effective at looking at things than we used to be. And I wanted to show you this simulation tool. It's the US Measles Simulator. And it shows you, for example, in a community, what happens if you have 80% vaccination rate versus 95% vaccination rate for measles. And you can see on the case here, where there's a 95% vaccination rate, there's herd immunity, so there are fewer cases, and basically the epidemic just burns out. Whereas when you only have 80% vaccination rate, you get a huge number of cases and a big outbreak. And we learned that by having these kind of new tools and new simulations, we understand things better and we can modify people's behavior. So Robert's going to spend some time showing you the new Pedestrian simulator and see how we can apply that to COVID. So I'm going to turn over the screen to Robert.
Cool. Thanks a lot. Let me share my screen. Okay, can everyone see that all right?
Yep.
Cool.
That's good.
Thank you. So just a little bit about me. I'm a fire protection engineer with Coffman. Originally structural engineer, fire protection. Fire protection is a bit unique, probably more natural to have medically minded people involved in this. But fire protection actually has some pretty direct and perhaps surprising applications that as part of being a fire protection engineer, we're very often involved in human behavior and the different mechanisms for which, especially buildings, are going to impact a human response. Generally, we've been looking at evacuation scenarios, but with COVID, we're looking at a slightly different scenario. So I will share some of the tools that we're using in order to utilize engineering analysis that has often been done for evacuation scenarios for this new environment. So before launching into it, this all kind of fits within the goal of trying to reopen and re-enter society prior to COVID-19. So what we were used to doing as highly social human beings, we like to engage with each other. And of course, that is where a lot of the risk is coming from in terms of transmission from different populations. So as part of the reopening strategy, we're focusing on a couple different areas. Of course, achieving business and operational needs around some of that continuity, just getting back into the workplace, trying to protect, if you will, employees and patrons, and of course, focusing around what is best practice around mitigating some of that risk. So I think we're all familiar with the importance of sanitation, facial coverings, and what we're doing is we're proposing a tool around trying to enhance the capability to physically and socially distance when we are reentering some of those populations. So in terms of fire protection, what we've often looked at is evacuation scenarios or emergency scenarios where we can model human behavior in response to some sort of event or some sort of threat, and evaluate how occupants are able to evacuate from these spaces. So this is kind of the traditional way of doing things, and it really is putting yourself in the shoes of what someone might be experiencing and making sure, not just from the human behavior point of view, but also from the building point of view, that we're able to accommodate a response, in this case, evacuating the building, that is going to be acceptable. So of course, we're looking at a different scenario now with COVID, that we're seeking to try and physically, socially distance from each other. And so there's new considerations that are important to be aware of as we're seeking to try and re-enter and assimilate into this new environment as businesses are opening, as we're starting to have different events, things like that. So as Tracy had mentioned, we're alluding to a couple different mitigation efforts that we as engineers and architects and as patrons can utilize. Of course, one is building HVAC systems, which Tracy is a great person to talk to, and she's going to talk a little bit more about that after this, after I present pedestrian simulation modeling. But we're going to focus more on physical and social distancing. So when I say physical distancing, what I mean is looking at some of those static conditions. So what are the things that we can do to create physical distance from each other? And this is generally around continuously occupied areas. So this is something we as designers and architects can look at a traditional floor plan, and we can start to separate our desks, our workplaces, conference rooms, things like that. So somewhat straightforward, which is really positive. But as human beings and as social and dynamic creatures, social distancing is a little bit more complicated. That what happens when people start to move, then those static plans that we're looking at start to become a bit challenged. So how do we maintain that 6-foot separation? Currently is that best guidance from CDC and a number of organizations. And what other checks are we going to have in order to verify or kind of evaluate the risk or certain indicators that might indicate that we might have to isolate certain populations. So there's things that we can do in order to evaluate some of these criteria and try to implement these best practices. So some considerations that go into that, even before we do the modeling, is firstly understanding what the built environment is. And so one way to think about this is the architecture and the engineering. So what is the domain that occupants or patrons or pedestrians could navigate within a space? What does this mean in terms of different flow paths, entry and exit conditions, especially vertical egress? I'm sure we've all seen bottlenecks at stairs, escalators, ramps, things like that. But understanding some of these considerations. This is where fire protection engineering starts to become a bit more relevant, is not just looking at the architecture and engineering, but also looking at human behavior. And so it's trying to understand what the experience of the occupant would be and what some of these goals are. And of course, there's quantitative metrics that go into that. And fortunately, in the field of fire protection engineering, a lot of this is quantified based on available data that can be utilized and applied in a number of different ways. And when we start to get into COVID-19 management procedures, looking at that more dynamic environment, we can start to utilize and apply some of these different considerations that we're starting to have to pay attention to into these models, into simulations. And it's a really powerful visual tool to graphically and analytically show what this sort of response would be. So this video that we're seeing right here is the application of the 6-foot separation, showing that occupants are really seeking to distance from each other, and what that means in terms of the flow and the movement within the space. Another way to evaluate this is if we're going to have, say, screening or temperature checks, understanding what that means in in terms of the markers. I'm sure many of us have tried to go to the grocery store and had to wait outside for a little while. And so understanding realistically what that means in terms of different management procedures, and maybe there's a way to entertain people if we know that we're going to have a 20-30 minute queue waiting outside. And then another way is acknowledging that in the traditional sense where we're able to evacuate, we're able to be closer and have tighter densities to each other, trying to look at ways to reduce the number of interactions or the amount of interactions, or another way to look at it is the density of occupants within the space. So something like a one-way flow. So again, we've probably seen that at the grocery store, all intended to try and minimize the number and the amount of interactions to try and have a more efficient directional movement within spaces. So in one way to think about it, it's something of a digital due diligence that as we're all trying to focus on reopening and preparing our workplaces, our sites, our offices, or potentially even larger event centers and the like, to be prepared to try and protect and mitigate some of these risks of transmission. It's important that we're very clear about what it is that we're actually trying to achieve. And there's a number of sources available. I'd highly encourage everyone to take a look. But this is something that I thought was really interesting, something that Tracy shared around the hierarchy of controls. And so there's a number of different, say, steps, if you will, that we as occupants, as designers, as managers can utilize. And this type of tool is kind of within these engineering controls that where we are seeing a greater level of risk, say we're located in a hotspot potentially where there's an outbreak, or we're especially concerned about vulnerable populations or something like that, we're able to utilize additional measures to try and control that risk. So it would be great if we could eliminate it, but within kind of the realistic bounds of our current situation, try to control that risk. So we're quickly going to look at a case study and what that looks like. So we've looked at a number of different organizations, situations, clients, and we thought that this one was maybe a little bit easier to recognize some of the value, primarily because it's a little bit smaller. And so I'll share a little bit about some of the considerations about larger venues at the very end here. But this is an art gallery and design exhibit, primarily assembly occupancy. They seek to have large galleries, exhibitions, large events. Of course, that's not feasible within, probably not feasible within our current environment right now. So helping this gallery to understand what it is to reintroduce occupants and patrons within this environment and what this is going to mean in terms of trying to achieve some of those social and physical distance practices. So a quick little overview of what the gallery looks like. We have a large outdoor arcade, entrance arcade on the outside, and it's a primary entrance coming into this mezzanine area, an entry desk where occupants are able to get information, learn about the artists, learn about the different installations, and then proceed down the stair into the large open gallery area down on the bottom where there's a number of different installations, there's different spaces to traditionally interact with some of the installations. Of course, due to sanitation reasons and contact, that was recommended to not be encouraged or utilized within the space. So that's something that the organization has sought to remove, but a number of different considerations there. And even before we did the modeling, there's a couple different items to think about. Firstly, knowing your business, knowing your site, knowing your patrons, of course, is a big one. What is the experience that you're trying to curate? And of course, being clear, what are our priorities that as we're entering this COVID environment, what is it that we're trying to achieve by doing so? So in terms of knowing the business, first of which probably the reality of the situation is knowing what the business objectives are. So of course, many businesses are seeking to reopen and get closer to the pre-COVID conditions. And so what does that mean for this organization? And so we might speculate on that, but of course, it relies on a level of interaction and engagement with the organization. So one of the key points that I thought was really interesting and really enlightening for me was in talking about the business needs of this organization, donations were a very large facet of how they were able to financially support themselves. And one of the key aspects of getting donations is to be able to facilitate that face-to-face interaction and share some of the details around the local presence of the artists and the impacts they're having, some of the different events and organizations, and especially some of those philanthropic efforts that the Institute here is having. And of course, this is relying on being able to spend time and have a conversation with your patrons, which comes with associated risks. So it's a business reality, but something also that needs to be taken into consideration as part of the social and physical distancing. And so because of that, that was something that was kind of highlighted as a priority with the reopening process. It would be great to be able to open the doors and try and distance some of the staff or the patrons from each other, but that simply wasn't a reality in this case, or really one of the constraints. And of course, one of the other constraints is going to be the site itself, so that architecture and engineering. And so identifying some of those key hotspots even before we did the modeling. So acknowledging we have a large outdoor space, trying to utilize some of the queuing on the outside, that if we're going to have a temperature check, or if we're going to have this conversation about donations, about the intent of the space, some of the background of the different artists, it's encouraged to occur at a location where there's maybe a little bit more ventilation, have a plastic screen or a barrier up to try and mitigate some of that particulate spread. Getting down into the space, identifying that we have the potential for a directional flow down and up. We actually wanted to use the stair over here, but what the organization was seeking to do is try and have a donation box at the exit as well. So entry in one side, coming down, and then exit out the other, and then have a donation box at the end over here. So understanding you could potentially have bottlenecks at the top and the bottom of the stairs. This stair was considered to preferably be available for evacuation scenario, but not for this COVID environment. Looking at different dead end possibilities, make sure that trying to mitigate the interactions between patrons in this location. We have an elevator over here, so another potential queuing location. So a number of different considerations taken into account even before doing the modeling itself. Looking at the patrons, seeking to try and have something resembling the original occupation of the space. I don't know that we'll be able, or probably is not recommended, to have the density and the number of patrons that they had before, but seeking to try and figure out what a reasonable maximum number could be within being able to achieve that density limitation and being able to confirm that occupants are going to be able to space out if they're within that 6-foot bubble, if you will. And one of the important keys is really putting yourself in their shoes too. So understanding what it is, what experience it is that we're trying to curate in this space. We want to be able to enable people to be able to wander and explore and to be able to spend time with the installations and get up right next to it. So we know that we're going to intentionally try and not have as many occupants so they're able to be comfortable within the space and interact with the artwork in a way that is conducive to what the gallery is intending to do. So in terms of some of those priorities, of course, well-being and health is one of the top priorities for any organization, but being able to achieve those business objectives and be able to curate that experience. And so what we did even before we did the model is try to identify some acceptance criteria, if you will. So what is acceptable and what might be less acceptable even before we do the model, so we can look at the results of the models and then evaluate the performance. And then we can collaborate with the organization to understand what sort of changes might be appropriate. So finally getting into building the model here, one of the first steps is to understand where our domain is. And so we have a large outdoor arcade, we have this entry lobby, we have our vertical paths of ingress and egress and flow within the spaces, and identifying where front of house is, where back of house is, and making sure that we're aware of the different areas. Of course, the installations are another key aspect of that. So working with the organization to understand not just diagrammatically, but also kind of physically what a reasonable obstruction might be in terms of where occupants can't go. But in addition to that, highlighting where we want them to go. And this is probably one of the keys that's unique to this space, and really understanding the unique needs of this gallery is some of these areas right in front of the installation are going to be areas where we're actually going to want and encourage and enable some of the patrons to be able to spend a little bit more time and to be able to really spend some time with that artwork and to be distanced with each other all the same. So I think it's really important to be able to have some of these open spaces, but the distribution of patrons is an important consideration in addition to some of those overall goals. So what does that mean in terms of the model? As we're looking to build it, we're trying to build in some of these physical barriers within the space to physically distance from each other. So we have some queuing on the outside, we have our one-way flows, and we're really trying to utilize, if we can think of a one-way directional flow, not just in some of these locations, but seeking to implement something of a counterclockwise flow here. So as you come down, you're moving around this location, and with everyone moving in the same direction, hopefully they're also being aware of their social distance from each other as well. So incorporating some of those patron behaviors, some of those quantitative metrics, how long do we find kind of on average that patrons are going to be within the space? How many people do we anticipate? What do we think is a maximum number of occupants that could be utilized within this space within these current conditions? So a far cry from the 250-ish occupants that they might have in a pre-COVID situation, but somewhere in the estimate of 20 to 50 patrons, and that's something that the business would be pretty happy with. Incorporating some of these physical and social distancing parameters is important as well. And so when we're looking to try and do that, we can apply a wait time, so simulating some of that interaction with staff as the different occupants are entering within the space, and creating almost waypoints, if you will. So assuming to some degree that each of the patrons is interested in checking out the different installations and the different pieces of artwork, having them kind of move along together within a path. And this is something that we might be specifying, but it is something that we can also randomize as part of this assessment. So there's a lot of flexibility in ways that we can direct and kind of manage the patron movement within this space. And what does this look like? It's very much an iterative process working with the organization. So one of the first steps we did is look at, well, what does something like 20 patrons look like? And so of course this is fast forwarded, but we can see that different patrons are coming in, spending a little bit of time at this entry location, and then spending time with the different galleries, installations. We can see that they're pretty well spaced out. So we have a couple occupants that are somewhat close to each other. We can see that they're maintaining that 6-foot separation. And so looking at this is actually something that could be considered a pretty effective means of applying that physical and social distancing within the space. So one of the benefits here is we can graphically see that at first glance, there's no real red flags. So what does that mean? Maybe there's an opportunity to increase the number of patrons and see if we're able to accommodate this sort of behavior with a greater number of occupants. So we kind of shot for the moon on this one, and we went up to about 50 patrons, and we can see that all this behavior up at the entry it seems to be acceptable. This one slowed down a little bit compared to the first one, but we can see that with the greater number of patrons, it's having a pretty significant impact on the flow within the space. And one of the primary concerns, while they're able to maintain for the most part, that 6-foot density, we can also see that they're challenged to be able to become intimate with some of that artwork, that they really are trying to have to be careful and manage their behavior within those spaces in order to maintain that separation. And maybe they're not able to really focus on that artwork. And maybe this isn't as comfortable in an environment as the organization would like to, it really intends within this space. So we can look at some of the output from that. So graphically, we can see that maybe this isn't the behavior that we really want to encourage, but quantitatively, we can also see what that means. So we can look at some of those hotspots and some of the different areas where we are seeing a greater level of interaction between some of those patrons. And there's some different ways to try and mitigate that. Obviously, decreasing the number of patrons is one way to do it, but maybe there is greater staff management in those areas. Maybe we help to try and locate different staff at these, maybe at the bottom, there's a large entrance board over that people can read in this location, so maybe they can be directed there's different opportunities in order to try and mitigate that. But probably one of the more direct ways, acknowledging some of the limitations of the number of staff due to financial concerns, due to another just kind of business realities, is trying to create an environment in which patrons are more or less policing themselves and socially distancing without having to be too actively reminded by staff to behave in this way. So looking at something about 30 patrons, this seemed to be the sweet spot for the organization. So based on the graphical model, we can see that there's a little bit more interaction, and we're seeing people starting to get within that bubble a little bit. But for the most part, they are keeping their distance. They're able to spend some time within those installations. And this sort of experience is something that the organization thought could be acceptable within what they're seeking to achieve. So they're actually opening up next week, which is really exciting. So we're all very interested to see how this goes and how this matches to reality. But all of this is starting to be documented and implemented in their reopening plan that each of the organizations within, it's actually a large cultural center, is required just by kind of the local area to produce in advance of opening. So it's great to see that they've been mandated to put some thought into this. It will be interesting to see if other localities will also be mandated to do so. But pedestrian simulation modeling is a tool that can be utilized to graphically and quantitatively show, kind of do a digital due diligence, if you will, what reasonable occupant capacities, maximum flow rates, things like that, densities could be, and how staff can be deployed, how this can all be managed in order to get the experience that we're all seeking to enhance within these new environments. So we're curious to see how this goes. We're really interested to, once the organization opens up next week, to really work with them and continue that relationship and to validate our models based on what they're actually seeing on site. So perhaps people want greater distance from each other. So right now we have 6 feet, we can go to something like 7, 8 feet. There's a number of different parameters that we can modify. So it's really interesting. It should be very insightful. So of course, that's a small scale example. And what happens when we start to look at larger events that as we're seeing increasing reopening, I think we're also seeing larger events seeking to try and open up as well. Remains to be seen if we're going to be able to have, in this example, fans. So this is something that simulates maybe a university or some sort of large event where they have a sporting event. We have this huge rush of people trying to get in right before kickoff or first pitch or something like that. And so being able to model the situation and understand based on the available ingress or the egress, entrances, temperature checks, screenings, numbers of people, maybe the way that we've been doing things in the past where we allow people to show up at their own leisure. Maybe we want to have a phased entry, or maybe we want to target them and ask them to go to different strategic entrance points to try and mitigate some of that movement around in the different spaces. So this is one way that tools, especially for larger events, can be useful. We're starting to hear more conversation about schools and universities open, and I think a lot of these considerations also apply. So it remains to be seen how this is going to be deployed, but pedestrian simulation modeling is one tool that can be utilized as part of that digital due diligence to show that this is something that can be feasible, that we can open up, maximize our classroom space, maybe have a combination of web learning and physical learning in person. Maybe we're going to have phased classrooms or schedules or teaching sessions. Maybe it's coordinated with mass transit to try and limit the amount of time that people are interacting with each other. There's a number of different situations and considerations. And at least in my opinion, I think it's valuable to think about these in depth before we go and we open up. And as Tracy mentioned, as Tracy's going to talk about a little bit more in just a second, some of these indoor events are starting to open as well. And so just acknowledging some of those considerations around physical and social distancing, some of that particulate building controls around ways to mitigate some of that risk of transmission. So as these events are starting to happen, just being aware of some of the things and considerations and thoughts that perhaps should go into this before we decide to have these events. So that's just about it. So we've talked quite a bit. Of course, sanitation is really important, physical, social distancing important, and we're seeing a lot more guidance from different organizations about what some of those reopening considerations might be. And hopefully in the last 40 odd minutes, we also have a better understanding of how pedestrian simulation modeling, fire protection engineering can be utilized to help that process, really go through it and have a better idea of what having people in these spaces looks like before we invite them back in. So with that, thanks a lot, and I will hand it back over to Tracy.
All right. Thanks very much. Okay. So, get a better view this time. So now looking at the pedestrian modeling, we see where we can do things to the built environment that mitigate by doing one directional flow, limiting the number of people, those kinds of things, and we can make improvements. But there are going to be situations where we can't make it much better and people are going to be closer together than we want them to be. So then we start looking at other opportunities. What else can we do to the built environment to mitigate risk? And there are a whole host of different things we can do, and I'm just going to share a few ideas with you to get some conversation going. So we can look at airflow patterns, moving things from clean to less clean. We usually say that instead of clean to dirty. So the way that an air moves in a space, we're concerned if we have somebody in a space with a window air conditioning unit and it's blowing air at somebody, what if they're infected and then that air is blowing over across the room to somebody else? So anytime you have air moving from one person across multiple people, you're increasing the risk because we know that there's a lot of asymptomatic spread that can occur with SARS-CoV. So we can play around with diffuser layouts and adjust airflow patterns in the room in some case. We also can make rooms negative or do source control. We think of that more often in the past with laboratories and healthcare environments, but we can do things like that in other spaces, not just labs, healthcare, where it makes sense. We want to try and control some risk. We can also play around with the furniture layout. Hinted a little bit about that with the pedestrian modeling of how the space gets configured, but you can move chairs and tables and things, not just to create space, but to also put people in a better pattern of airflow in a room. And then a lot of folks are asking about these recirculating HEPA filter units, and is that good? Should I put one in my space? Do I set them up all around my office? And how many do I put per square foot? One thing that we know is that these airflow patterns really matter. So where those get placed, what direction they're blowing out, what direction they're drawing in from makes a big difference. Kishore Kankari is a CFD modeler that is a colleague of mine. I've asked him to run some sample simulations of those to start trying to get some better parameters for design and guidance for people on those kind of systems. And I want to talk for a minute about the difference between filtering the air more versus bringing in more outside air. And some people want to know, well, what's better to do? Should I bring in more outside air? Should I add better filters? What if I can't do one or the other? What does it matter? So this chart will give you an idea. This is for a 500 square meter, which is below 5,000 square foot office building. And what it's showing is this measurement and mean relative risk of infection. And then what happens when you filter a building or bring in more outside air. And the outside air are these colored lines. So like in Phoenix, if you don't bring in much outside air, it's very cheap, you're not using a lot of energy, but you have a higher risk of infection. And as you increase the amount of outside air that you bring into a space, the cost is going to go up because you have to condition that air, and it's hot in Phoenix most of the time, but you're going to lower your risk of infection by adding extra ventilation in that space. If you look at filtration, MERV 4 filter is kind of a variable refrigerant flow ceiling cassette type filter. You can get about a MERV 4, and that's about the best you can do. A lot of pre-filters in air handling units are MERV 7, and then you start getting into some of the LEED buildings where we see LEED or MERV 11, and MERV 13, 14 really seems to be a tipping point in terms of filtration for a space where you're getting a lot of benefit in terms of capturing viruses that may be attached to droplets, but the cost hasn't gone up a lot compared to MERV 4 or MERV 11. Once you start going beyond MERV 14, you start getting into what we use more in a pharmaceutical or a healthcare application, and the cost goes up considerably, and there's not very much benefit in terms of infection rate. So just gives you an idea of something to consider. I have some other information that I could share where we looked at pros and cons of ventilation versus filtration. We talked about those things. There's also options to do disinfection. So UV lights are very well proven. CDC's been using them for tuberculosis control for decades, and there's a lot of really good published peer review research on it. You're going to see a lot of information now out there about other kinds of disinfection cleaners and ionization units and things like that, and people are wondering about that. And it's really important to evaluate the claims, looking at whether or not there's research from peer-reviewed journals that are very reputable versus third-party studies, which is often just the manufacturer just paying another company to run the test for them. Very different from something that's peer-reviewed. And then some of the tests happen, like there's one product where the test happens in this very small container with very perfect conditions, and they're not even comparing what would happen to the death of a virus. If they didn't do anything, they're just saying a lot of the virus died. But how do you really know if that's because of this product or the virus would have just died anyhow over that length of time? Is the product supposed to be used in a static condition, or is there a bunch of air moving through an air handler and it's supposed to kill the virus? So important to think about that, because there's a lot of promotion of products that maybe aren't as effective as you might think at first. Considering things in the built environment like hard floors versus carpeting, where carpeting is much harder to clean and holds a lot more particulate. Putting lids on toilets is another biggie. And then I'd like to spend a few minutes talking about another idea that I have that is something that I'm real passionate about. So when you think about people coughing, you think about particulates coming out, but a cough is really a lot of liquid, and it spews out at a great distance. And what happens to those droplets is very dependent on what the air condition is, the temperature and the humidity. So if the humidity in the air is really low and dry, those particulates can desiccate, and the moisture in the droplets dries out, and what's left is a smaller aerosol that can float in the air for longer distances. And if the air has a higher moisture content, then the moisture stays in those droplets, and those droplets tend to fall out and drop and not travel as far. They also don't get inhaled as deeply into your lungs because they're bigger particulates, and they get caught in the cilia, which is the hairs that line your bronchial tubes and help clear your airway and keep particulates from getting down into your lungs. So this diagram just shows here some different sizes of infectious particulates. The coronavirus, SARS-CoV-2 is about 1 to 2 microns, but again, it's much larger when it's in droplet format. So there's this study that happened a few years ago. They wanted to look in a hospital at the patient environment. They looked at 5 patient rooms on one floor, 5 on another floor. There was a med surg and an oncology. And they measured all kinds of parameters. It's called the Microbiome Project. And they were looking at how microbes travel through a new hospital. And fortunately, they also ended up taking a look at healthcare-associated infections during this time period. And they collected a whole bunch of data. And at the end of it, there was an analysis done by a colleague of mine, Dr. Stephanie Taylor, to look at was there anything correlated between the healthcare-associated infections and all the different parameters that were measured with temperature and lighting levels and room traffic and the air change rate. And there was only one parameter that mattered, that was correlated with the healthcare-associated infection rate, and that was the room relative humidity. So on this chart, you can see when the room relative humidity was around 32%, there were a lot of healthcare-associated infections. And as the relative humidity increased during part of the year in those rooms to above 40%, the number of healthcare-associated infections dropped off dramatically. They also were doing PCR analysis on swabs that they took in the space, on people's hands, on surfaces in the air, and they were looking at the diversity of the microbes in the space, and they found that there was a correlation also with the diversity of microbes, because having that moisture in the air prevents some of those microbes from going away. We also know that there have been a lot of people, unfortunately, who have become infected and who have died from COVID-19 during this pandemic in long-term care facilities, residential healthcare facilities like Alzheimer units, nursing homes, and hospice type facilities contacted us and saying, hey, what do we do? We need some help here. This was a study over 4 years to look at the indoor and outdoor climate and to see what that might do with infection rates. And what they found is that for respiratory infections and also for gastrointestinal infections, the level of those was way down when the relative humidity within the space was between 40 and 60% RH. The Mayo Clinic also published a study in 2018 where they took a preschool and they took several rooms in a preschool, left them unhumidified, and took several other rooms and humidified them up to 45%. And then they sampled the space, did PCR analysis, looked for influenza virus in the space, and long looked to see not only was there virus, but how viable and infectious that virus would be. And these are the numbers they showed in the classrooms where there was no humidification, a much higher level of airborne particles with virus. Those particles were more virulent, and they had a lot more students that were absent due to influenza type illnesses during that case. Last study I want to share with you is PNAS. It's a great journal, and there was a study that was done by some Yale scientists about ambient humidity, and they set up a study where they took mice, and they had to do it with mice because they ended up cutting up their lung tissue to inspect them afterwards. But they put them in two different chambers, a 20% relative humidity chamber and a 50% relative humidity chamber. And they left them there for 4 or 5 days, and then they infected them with influenza, and then they left them there for another 7 days and then took them out of the chamber and compared the difference between the two. And what they found was that the cilia in the throats of the mice did not work as effectively at moving and taking particulates out of their lungs. And the same thing happens in humans when we get dehydrated and we're in breathing dry air, is that our lungs aren't protected as much by the cilia. We also have a first line immune response called interferon, and that's basically our body protecting us from infection, and that gets diminished in the dry air. We have decreased inflammation and tissue damage when we increase the relative humidity and have better indoor air hydration, and the repair of our cells is also better. There's some neat research going on now with things called organoids, where we take some cells from one of our organs and grow another tissue culture that's similar. And they've done some studies. This is a picture of a liver organoid infected with SARS-CoV-2. And we've learned that there are different parts of our body that actually get infected with the SARS-CoV-2 virus. So they're studying how is that impacted, and we're hoping that they do some studies on that with relative humidity as well. So when the relative humidity is below 40%, you get a lot more infectivity. It's hard to clean spaces. When someone coughs, it's going to travel further, and the viruses just survive longer. This is a preliminary study done by the Department of Homeland Security, the biodefense folks put this together, and they looked specifically at SARS-CoV in darkness, at different humidity level, in the sun, partial sun, and at full sun. And they found that there's quite a bit of decay of the virus when you get a lot of solar gain and a higher relative humidity. They did this one was for aerosol. They also did it for a number of surfaces. And a colleague of mine also made a graph then from that data of the half-life at different relative humidities and found that there is a sweet spot for the virus in this maybe 52 to 70% relative humidity. We usually try to stay below 60 because we don't want to have condensation when there's cold environment. But this is a little update on a chart that's called the Sterling chart. It was first published in 1985. that talked about different pathogens and where they were more infectious at different relative humidities, that showed there was this nice zone in the middle, kind of in this 40 to 60. Depends on exactly what pathogen you're talking about. But recent studies shown down here in the red and in the blue, there's another one I didn't share with you, Well Built for Well-Being, that shows some big differences in productivity, sleep quality, and student learning when you keep the relative humidity in that sweet spot in the middle. So these are other things that we can do to try and improve the built environment and reduce infectivity when we can't keep socially distanced and just stay all alone at home like many of us do now. This is a return on investment showing 500% in the first quarter if we had gone into that original hospital study and added humidifiers and figured that we would lower a small percentage of the healthcare associated infections just by increasing the relative humidity to a minimum of 40%. So pretty good payback. The money talks. And lastly, this is the ASHRAE Epidemic Task Force that I'm on. I lead the healthcare group, but we've been putting together guidance ever since the pandemic came out. The group assembled in late March, early April. And we have a web page. There's all kinds of great information in there about reopening, advice for schools. Residential section is very helpful. There's healthcare facilities, big section on filtration, disinfection. So encourage you to go check that out. There's just a lot of great guidance, and we're still learning more every day as papers are published and coming out about what we still have questions about, and we're trying to learn about the spread of COVID-19. So the pedestrian simulation modeling is really one way that we can help improve situations as we try to reopen and get back to work. So look forward to answering your questions. Really fun sharing this with you. So I'm going to stop the screen share and let everybody else pop up their videos, and we'll go ahead and take a few questions. I think we'll look at the chat. Bryson is going to help us moderate on that. I'm not seeing any questions up on the Q&A just yet, so if you have some that you'd like to ask, please feel free to go ahead and type those in. Robert, I don't know, are you muted? Can you hear me?
I can hear you all right.
Good.
I have a question. What sort of response, I guess, have you seen thus far? I know focused around healthcare, that's a huge priority for different facilities right now, but with different businesses that are starting to open up, what sort of engagement or what sort of modifications have you seen, and what are some of the maybe high priority things that they can be doing?
A lot of facilities are trying to do things with plexiglass, trying to prevent that spread. I saw a nice study. Some people were asking about the difference between wearing a mask over their face versus wearing one of those plastic face shields. And a lot of that comes down to who are you trying to protect? You know, we don't really know who's sick all the time. People are doing scans for temperature, and we know we can catch maybe 40% of the people that are infected at the right time that have a fever, but a lot of people don't. So we don't know really who's sick or who's not, but a mask is going to prevent, for example, if I'm sick and maybe I don't know it, a mask will prevent me from spreading cough, sneeze, particulates to somebody else. So when I wear a mask, a lot of times that's just in the sense that I'm trying to protect you in case I'm sick and I don't know it. A real high quality mask that has a really good seal on it, like an N95, is going to protect me from somebody else that's infectious by filtering that air before I inhale it. The masks that have the little vent valve don't protect you from me if I'm sick as much. The face shields are pretty interesting because they do a pretty good job. One study that I saw that was published showed at larger distances, 6 feet or so away, they were preventing about 99% of the contaminated particulates from entering somebody's breathing zone. And just, you think, oh, that air is going to go up in there, but it really diminishes that from another person. and it that can help a lot with reducing infection in your eyes. So wearing a mask combined with a face shield, if you're trying to look out for other people, plus prevent yourself from getting infected, is helpful. We're seeing people do the plexiglass shield, a lot of the staging areas, and trying to limit the number of people that are waiting in a space. Folks are using UV light more and using portable HEPA cleaners. I've had a lot of calls from people who are in a dental facility or an ophthalmologist saying, what do I do in my exam room? And so we've been coaching them with different options. You know, when you're really close to someone, wearing the mask is essential, and the face shield, because the HVAC system isn't going to really prevent someone from getting infected when they're really close together. But we're helping them with things to clean that air out and try and reduce that contaminant concentration in between patients, you know, where you can clear that air out too, because someone like an orthodontist could see 100 patients in one day. So their exposure is really high.
Did have one question come up, and Stephanie, you might be able to answer this. Is this going to be available to share with colleagues who weren't here to see it?
Yes, we are recording it. I'm new to Zoom, so I need to get it. We can go ahead and post it on our website. So we are recording it though. So I will work in the next week or so to see if we can get it up on our website, and that way people can have access to it.
Okay. All right.
Any more questions?
Well, we're right at 1 o'clock, so good timing. Thanks everyone for joining us.
Well, thank you, Coffman, for putting together such a timely presentation. I think it was fascinating, and you know, the story will continue for sure, and the study will continue. So we'll be anxious to hear more from you as it evolves.
Right.
Great, thanks
Good.
again. Appreciate it. Thank you everyone for joining us. And our next one will take place July 8th with Geoengineers. So if you need more credits or find the topic interesting, make sure you sign up for that one as well. Have a safe and pleasant 4th, and wear your mask.
Yeah, everyone.
Thanks, Stephanie.
Thank you, guys.